Afternoon. Thank you for those of you that may have come back in my previous session. Appreciate you guys at the back, solidarity and all that. This next session, or this session is, we're going to look at a few different things. Primarily we're going to look at kind of some of the disaster recovery scenarios for SharePoint 2013. They apply equally to SharePoint 2016 as well. And some cases SharePoint 2010. But 13 and 16 is where we're really focusing on here. And the title of the slide says with Azure. It should say with Azure Site Recovery Services. Okay, just to extend it, and the abstract was quite clear there as well. So if that's why you're here, welcome and thank you. A little bit about me. My name's Neil Hodgkinson. I've done a number of different things at Microsoft. I'm currently in the CXP CAT team. But I've been around for a long time, and interests and hobbies, I seem to spend half my life in a plane, juggling my kids in the air. That's a famous statue from Oslo. Supporting Manchester United, beating people up and drinking whiskey. I was also a chemist in a former life, so dealing with drugs, poisons and explosives, so just be careful about the questioning. So we'll leave it there. If you want to ask me any questions later, this subject is actually a work in progress. There's a number of things and a number of changes as we develop this ASR capability with SharePoint. Of course, the new version of Windows Server is going to ship, and that changes the scenario again. And I'll hint to some of those changes as we go forward. What I'm looking at here is particularly what we can do today with Windows Server 2012 R2 and ASR. So what we're going to go through is I'm going to talk a little bit about disasters and recovery. I don't want to dwell too much on it, but we're going to cover off what is a disaster, what are the scenarios, what are the kind of features or the scenarios that you might run into for disasters, and what is the kind of critical business impact of suffering from a disaster. A few things about the terms, scenarios, and tools. So very, very briefly go through those. And then I want to get a little bit more into the concept of Azure Site Recovery. For SharePoint in particular, anyone in the house run their SharePoint infrastructure on Hyper-V? Or VMware? More on VMware. Okay, that's cool. There's a message here for all of you. Okay, hopefully will please everybody. And then I'm going to talk more specifically about SharePoint specific. SharePoint, as you know, has got a whole number of moving parts. Most of them need extremely tight synchronization with each other, or everything falls to pieces. So we're going to talk about what we can do with ASR and how it fits into the SharePoint space. So first of all, when we think about disaster types, there's really two. Right? There's a forecasted type event, so things that we can foresee. You know, I see a hurricane coming, it's going to hit my data center. I have some time to do something about that. Right? I can fail over and everything's going to be fine, hopefully. Okay, so I have planning in place to make sure that I can fix that. The second scenario is more of the unforeseen. So how can I fail over and make sure that I have enough protection in place within my infrastructure, either with dual data centers or with Azure perhaps, such that if something hits my environment that I'm not expecting, I'm able to recover from it. Classic scenario I've seen before with a data center was when a customer suffered an extreme outage when they building company was doing some work outside of their data center and severed the network connection to their data center. Okay, that's a classic case of an unforeseen event. A lightning strike on a data center, such as we had in the Amsterdam data center in Office 365, unforeseen. You need to make sure you can accommodate that and plan for that. So that's kind of the key thing, is about that previously. Accept the risk, know the risk, and plan for the risk. Okay. Then we think about disaster recovery, and really disaster recovery falls into a number of different categories. It's how do I get my environment running? How am I able to protect my business? And that's the critical reason why we want disaster recovery. Okay? Two statements there, both from Gartner. A company denied access to mission critical data for more than 48 hours will likely be out of business within a year. That's a pretty profound statement when you think about disaster recovery environments. I'm not going to ask if any of you have got an appropriately scaled and appropriately planned and appropriately tested disaster recovery scenario. But believe me, if you haven't, it's time to get one. And the second statement, 1 in 4 businesses never reopen their doors. So a DR scenario, or I should say a disaster without recovery, and they're done. Right? Game over. It's not only the fact of maybe I'll lose my business, maybe I'll lose my data, maybe I can keep running next week, but who's going to trust me that I have their data online? Who's going to trust me to offer services to them? That's why when we think about Office 365 as well, with respect to disaster recovery, our disaster recovery planning, our disaster recovery infrastructure, and our disaster recovery capability is just as important as all of the production stuff that we run to keep the service online. So if we have to fail over, to a secondary data center, we can. If we have to bring on new machines because we lose machines due to a disaster, we can. If we need secondary network connectivity, all those things. And the downside to that is it all costs money, and you're spending money on things you hope you never need. Okay? And that's kind of a bit of a point in fact that people don't want to spend money on things they're never going to need. Okay? Because it's a significant business cost, capital and operational, that you hope you never need. So just be wary of that you can't skimp on it. Right? You need to be able to surface your business, even though you've not necessarily built out an environment like such as we have, where we plan dual environments and everything's scaled the same way and built the same way. We equally hope we never need our disaster recovery scenarios and disaster recovery environments. But because we are offering a service, which is a financially backed SLA on that service, we have to make sure we have all of those features in place, all that capability in place. So a couple more statements there. And there's one statement on there that I think is particularly important, especially from a thinking about the cost of building a DR strategy and building DR capability. And that's the third one down. A disastrous scenario is not a business as usual scenario. Okay? When you're offering a service like Office 365, if we go into a disaster recovery scenario, we have to offer the same level of service. Right? In the ideal world, if we go into a disaster recovery scenario, you, our customers, won't even notice. It'll be an instant failover, an instant flip over, and everything's running fine. For most businesses, though, they can't scale that way. They can't build that level of infrastructure because there's a significant cost to it. And clearly the most important thing is just to make sure your business keeps running. If you're a retail outlet selling things online, you want to be able to be sure that you can at least continue to sell. I might not be able to sell 1 million items a day like I could do previously. Maybe I've got reduced capacity, but at least my business is still there and it's still running. If I lose that capability to sell anything at all, I'm in trouble and I fall into one of those 1 in 4 business scenarios. It's going to struggle. So it's the third one down that I think is probably the most critical one. And most things in terms of disasters then really hinge on planning, appropriate planning. Going through a planning process, I was a PFE for a number of years, and I worked with a number of customers who deployed SharePoint from 2003 right the way through to 2013. And what was very apparent was most of the customers had a very blasé approach to disaster recovery. It was like, oh yeah, we back everything up. We're good. We can recover. That's satisfactory for us. Appropriate planning is critical. And these 5, I don't know if you can read that very well, these 5 stages, make sure you understand the business impact. Make sure you understand the threat and the risk. You know, the risk of building your data center next to a volcano imposes significantly more risk than building it in the middle of a busy city. Okay, a different risk, but still potentially a risk. You need to make sure you plan all those appropriate risks. So what's the likelihood of something happening? What's the likelihood of a disk failure? What's the likelihood of a network NIC failure? Much, much higher than the likelihood of perhaps of a lightning strike or a major power outage in the area. So plan appropriately for those. Definition of impact scenarios. So what do I define in terms of I lose a NIC? What's the impact? Do I lose a server? Do I have redundancy in that server for that? Once you've thought about the impact scenarios, then you can plan appropriately to make sure you've got enough redundant disks, enough redundant network, enough redundant power, scale up and out using the concept of what we call fault domains. And then the second thing is really to document those requirements. So if I go into a disaster scenario, what do I need to do? What do I need to bring online? And what steps and what order do I need to bring things back online? It's critical that you have these plans. And it's not only a technology solution. Think about the people as well. You know, a good online operation will have people around the globe who can all manage the same infrastructure regardless of where they are. You know, we have emergency planning scenarios. We have offices around the globe who can take over and run Office 365 almost at the drop of a hat if they need to, you know, away from the regular performance, capacity that we have. So thinking about the requirements, we fail, we get a lightning strike, what do we need to do? We have redundant power supplies. We get a network severage, what do? We have redundant network capability. And plan and process, how do we engage that capacity? You know, it's not just a case often of switching the power supply on. Sometimes there's a lot more to it than that. And then finally, make sure you've got a significantly well-planned, well-understood, and available set of planning documentation. It's a joke you've probably heard before, and Wayne's laughing at me now because he's heard this one already. But we do have customers, I know of customers, who store their SharePoint disaster recovery documentation in SharePoint. Right? It happens. People do it. Okay? So just be aware that's not probably the most appropriate place to store your documentation. Perhaps you'll keep a copy there, but you might want a copy in a fireproof safe somewhere as well. So just be aware of that and constantly iterate. Things change, design changes. If you listen to the DSC session yesterday, Brian talked about the changing of server farms over time and having a desired configuration that you might start with, and then you suffer from drift. Things change, new web app gets deployed, a new solution gets deployed, new dependencies are delivered into the environment. Make sure that those dependencies are properly documented, not just in terms of how you deploy them and how you use them, but how you recover them in the event of a problem as well. And it sounds like a lot of speech and a lot of hard work, and it is hard work, but it's critical to make sure you get that right. And then the final point is probably the most important one of all: test it. Number of customers have never tested their DR plan. It's the classic scenario of, would we take backups, and when you come to restore them, can you actually restore them? With a DR plan, it's important that you can invoke a DR plan, and then not only invoke it to fail over one way, but also fail back. Okay? Again, the concept of Office 365, I worked in the dedicated team for a while, and in the Office 365 dedicated team, we used to do disaster recovery, full disaster recovery processes 2 or 3 or 4 times a month. Each of our major SharePoint farms, 50, 60, 70 servers in some of those farms, we'd fail the entire thing over to a secondary data center just to prove to our customers that we could do it. And it wasn't, we failed part of it over and the customer logs in and it's all good. We'd fail it over and the customer would come along and say, okay, here's my test plan. And then they'd go and do all these operations against their farm to prove that we'd failed it over properly, to prove that they could continue with their business. And that's so important. Test it, and test it again. Okay, having said all that, when we think about disaster recovery, 2 key terms, there's a number of terms you can think about here, but the 2 key ones: recovery time objective, how long is it going to take me to actually come online? And in Office 365D, those scenarios we was failing over 100 plus terabyte farms and having them back online within 15 minutes. That's because our staff were well drilled, our processes were well executed, well practiced. You need to do that whole practice over and over again. There's no point when somebody doesn't understand how to bring a database back online and has to go hunting through TechNet to find out how to do it. You need that. You need it slick and as much as possible automated. And then recovery point. How much data loss can you afford? In the D farm that I'm talking about, our failover, we had an acceptable recovery point of 15 minutes. We always hit less than 15 minutes, typically because we did log shipping in those farms every 13 minutes. So we knew that if we failed, we always had 2 minutes of spare time. So we were never going to fail that scenario, but because we planned it appropriately. It is possible with some technologies to get even lower than that. Near zero RPO. Near zero RPO is what you should really be aiming for, which is almost like having a highly available configuration for disaster recovery. And there are customers out there that do that, where they build synchronous technologies, synchronous replication technologies, not only for high availability scenarios, but for disaster recovery as well. And it is possible. The problem is, the closer to zero that goes, the more expensive the solution becomes. You start having to invest in the most expensive version of SQL, the most expensive networks, have more people at hand, have more hardware at hand ready to accept that failover process. So it gets more and more difficult. I'd say most customers I work with over time have an RTO of maybe an hour, maybe 4 hours. They bring the business back online in 4 hours is acceptable. Some are much longer. Some might be a day or 2 days. From an RPO perspective, though, they don't want data loss. Okay, so 15 minutes is probably realistic. 30 minutes perhaps. But most of them will say, we want 0 RTO and 0 RPO. Then you give them the bill, how much that's going to cost, and we've changed our mind now. We'll have 2 days and 2 hours. So just be wary of that as well. So things we're going to look at here. Disaster recovery options and tools. I'm not going to go into detail on many of these because I want to spend time specifically on the last one. So most of you running SharePoint, I should imagine all of you do backups. You're all taking SQL Server level backups of your data, content DBs, service app DBs perhaps. From a SQL Server perspective, you'll be using one of those technologies. Log shipping, mirroring, or always on availability groups. Is anyone using always on, by the way? Oh, good. It's interesting to see. So always on availability for HA and for HA and DR, okay, for the whole Hadron scenario. And then there's a bunch of third-party options. Some of them in the hub over there have got various solutions for recovering SharePoint farms, and far too many to mention. They all have their own plans and tested and methodologies for doing that. And then the final one, something that we've never supported previously with SharePoint prior to May of this year, is the concept of virtual machine replication. Now, the team that I work in, we frequently get asked by customers, can you please validate our disaster recovery scenario? Can you please validate this approach? And we're going to use virtual machine replication to replicate our running SharePoint farms to a new location. Okay? That's completely unsupported by Microsoft. Okay? We won't support you doing that for a number of reasons. The critical one being, it's next to impossible to ensure synchronization of all your data on multiple running VMs. If you're using Hyper-V, for example, Hyper-V replication today is an asynchronous technology. You cannot guarantee that your servers will be anywhere close to being synchronous. In fact, the best guarantee you can give is a 30-second window. 30-second window between a crawl database and a search index is a corrupt search index, is a failed scenario. Okay, so will we sign off on those designs? Absolutely not. Some things you can do. SAN level replication of content DB is absolutely fine. You know, shut down your entire SharePoint farm, replicate it to another location while all the machines are shut down and then bring it back up again. That's equally fine because you've preserved the state and everything's okay. With Azure Site Recovery, we've started to change the game a little bit. So 2 years ago, Microsoft bought a company called InMage, and InMage had a set of technology that worked with VMware, if any of you are using it with VMware today, to offer the capability to do virtual machine replication asynchronously, but within that asynchronous stream to inject synchronous timing points. So they would stop the replication at a certain point in time, all the VM changes would catch up, they'd effectively tag, or if you might put in a check mark in a log, and they would mark that as being a synchronous replica. They'd checkpoint that down to disk, and then they'd carry on replicating again. Microsoft purchased that technology off them, and we've introduced that, and it's been rolled into the ASR capabilities, so the Azure Site Recovery Services. What Azure Site Recovery Services gives us to do is a whole range of different things. Has anyone tried playing with this, by the way? Anyone looked at the VMware session this morning on ASR? There was a session this morning on VMware and ASR. It's pretty cool. It works extremely well. You know, you can have all kinds of policy-driven replication. You can set up all kinds of different timings, different locations. It works with SQL always on as well. So it's signed off by the SQL team. It's signed off by the Exchange team. And I'll show you a slide at the end that covers all of the different scenarios that we can support this with. Works with System Center, also works with VMware as well as Hyper-V. So we're not just restricting this to a Microsoft-only centric technology space. And it's also signed off and integrates very well with a lot of the big SAN vendors out there, the big SAN and storage vendors. So we can use this technology to do SAN level replication, as well as just relying on the tools that the SAN providers give you. We can use this capability as well. So we can basically say, we can checkmark the SAN replication with this virtual machine replication with this database replication and bring you a synchronous capability all in one go. And it's more and more and more. So today, with Windows Server 2012, the replication is asynchronous, and we have to do some kind of playing around a little bit when I'll come to talk about how it impacts SharePoint specifically later in the session. But it's an interesting scenario, and it's giving us more and more capability. It's kind of finally we're able to say to our customers out there, especially the SharePoint customers that come to me and say, can we support this? We're now able to say yes. Okay, so it's a very different message than we were giving previously, where we just said, no, don't do that. The way we kind of build this technology, if you think about it, it does a number of different things. So Azure Site Recovery is able to do on-premises to Azure. Okay, when I say on-premises to Azure, we're talking about physical machines, we're talking about Hyper-V machines, we're talking about VMware. So I just build this whole thing out. Basically, there's a number of mechanisms here, and we can replicate all of these things. So we build what's called protection groups, we build protected policies, and we are able to connect individual VMs directly to Azure. We're able to connect Hyper-V hosts connected to virtual machine manager through System Center directly to Azure as well, and obviously VMware in terms of the VMware server management that they have. We can connect that up there as well. So we have the whole scope of capability. There's a number of other things in there as well. It's not only just a case of, okay, go replicate. We can do other things like test failovers. If you replicate all your environment up to the cloud. One of the things I stressed earlier was about testing your failover. With this capability, we can test a failover. I can have a whole set of machines replicating, and I can just go, bang, failover, do a test failover. And it'll build the whole thing up in Azure for me, or on another site, all virtual, all built up, ready to run, and I can test run it and validate that it's going to work without taking down my production environment. And then when I'm finished with the test gets deleted and it carries on replicating and everything's great. Very, very useful capability. That's on-premises to Azure. We also have the capability to do on-premises to on-premises. So we're still using ASR. We're still using the Azure agents and the Azure endpoints to track and monitor the replication that's going on. But this time we're not replicating up into Azure, the machines. We're replicating site-to-site on-premises. So again, something we were never able to offer before from the Microsoft stack. Obviously, VMware had their SRM technology and a few other technologies. Again, technologies that we won't support, right? Even though the vendor claims they work extremely well. We can't sign them off because we haven't tested them. This solution, fully signed off, fully appropriate, fully works with SharePoint, which is what I'm particularly interested in. There are some foibles to SharePoint, though, that we'll talk about. But it's the ease of how this works is so critical. I mean, I'm going to do some demos. I'm going to hold my hands up. The last demo won't work, okay? And I'll explain why. But it's so easy to do. This feature is so easy to do. There was a delivery by the PM for the feature, Vishal Malhotra, at Ignite. If you go to Channel 9, pull down the Ignite videos. On the Friday, on the last day, he demoed all this feature and showed how simple it was. That was back in June of this year. So what does it do? ASR, we get synchronous and asynchronous replication, depending on the workload, right? SharePoint, we want you to be synchronous. We have problems if you're not. The current version, we can only do asynchronous replication with SharePoint. Now, I've already said that's no good for SharePoint, right? That gives us some problems. We can't do asynchronous replication of search indexes and search databases, but we have a story for that I'll come on to later. The key thing is, regardless of your business requirement, regardless of your RPO and RTO, you can build a solution that will work for you. There's a whole range of different ways to build this. As I've said already, on-site to Azure, fail back to on-premises if you wish. Azure to Azure is coming soon, so you don't even need to be on-premises at all. You can run the whole thing using Azure Fabric, so it makes it even more flexible. Number of different ways to do restore points. Storage history, I can store like 99 years worth of history of my farms in Azure if I can afford the storage, okay, or I want to be bothered. The whole process becomes an extremely simple, and not only a simple way to do DR, it's really cheap, right? If you think about what Azure means when we're replicating to Azure, we're replicating to machines that are sat in a storage container in Azure Blob Store. They're not switched on. We're not consuming IaaS resources. We're just consuming disk space. Disk space in Azure Blob Store is dirt cheap, right? We don't need to consume CPU, to consume memory, unless we fail over. At that point, we don't mind spending money because our on-premises farm's dead in the water anyway, right? So we need to build our business back up. If we look at the cost, this is a typical scenario. 2 web front ends, 2 application servers, and an always-on cluster. $378 a month to replicate that into Azure. Versus, imagine running that when you're replicating to another data center on premises. The cost of that data center, the cost of those people, the cost of that electricity and power and everything else that goes with it. This is a significant cost saving. Even if you were replicating 10,000 machines, it's still going to be a significant cost saving versus the dual data center scenario. Because we're only doing storage, if you imagine the scenario where you're doing on-prem to on-prem now, okay, you're going to have the second data center if you're doing on-prem to on-prem, but the overhead cost in terms of the ASR licensing or the ASR capability is $16 per machine. So again, it's nothing when you consider the cost of the operational cost of running always-on replication groups across multiple data centers and stretched subnets. It's an operational headache. It's a patching headache. It's a painful process when you come in to do that. By replicating the machines, by replicating the storage, you ease all that transition and make it much, much simpler. Data costs. So this is kind of interesting. If you're running to Azure, there's obviously a cost of data transfer. As soon as you transfer data across boundaries, either from on-premises into Azure or Azure to Azure across regions, you're going to start incurring costs. But they're not huge costs, right? There's a one-off cost for replicating the VHD. So if it's a full-size VHD with a single disk of like 123 gig, you're fine, right? It's not a massive cost. It's a few tens of dollars to get the machine up there and continue to replicate it. And the critical thing is, we don't replicate a 123 gig disk if you don't need all 123 gigs, right? We just replicate the used space. So that's kind of critical. And then finally, there's a few other points around things like, if you're compressing your data, and when you're doing the deltas for replication, we're only replicating the small changes. So in terms of overall cost, by comparison of running another infrastructure on premises, significantly reduced. And it takes away a lot of the headache for you. So what can we actually do? When we're doing this, there's a number of ways to connect up. We can go direct over the public internet. So if I'm connecting my on-premises Hyper-V servers to Azure and replicating into Azure, I don't need expensive connectivity. I can just go straight over the public internet. As long as my on-premises virtual machine manager farm can connect out to the internet and reach the Azure endpoint, that's all I need. Okay, I'll just replicate out. It gets a little bit more complex when you're coming back in, but that's fundamentally all you need to replicate into Azure. I can do site-to-site VPN if I want a more private connection, or I can use ExpressRoute if I want more speed and again a more private connection. A couple of limitations. We don't support VHDX yet, but we will. If you replicate a VHDX VM from on-prem, so if you Generation 2, for example, as another option, we will convert it back to Generation 1 in Azure. Okay, so you can replicate it. We just won't be a Generation 2 when it arrives in Azure, when you spin it back up again. And then the downside to that is if you go into Azure, replicating into Azure with a Generation 2 machine, we convert it to Generation 1. If you then fail back to on-premises, you'll fail back as Generation 1. Okay, another thing to think about is if we're replicating physical machines, so we can replicate the physical machine as well as just the Hyper-V machine. When you replicate a physical machine to Azure, it replicates as a Generation 1 VM. We cannot fail back to raw tin on premises, right? So if you fail back, if you go physical to Azure, when you fail back, you go Azure to virtual. Okay, so you need a host for those machines. You can't fail back to physical. Excuse me. The way we build this thing. So there's a number of things we need to do. There's components you need to install. There's components you need to install on the virtual machine manager. There's components you need to install. Depending on what virtual technology you're using, you install components in different places. One of the key things is this concept of the mobility service that communicates to the process server. As I mentioned already, when we're replicating all these changes out, we need something up in the cloud or something located on premises, in fact, if you're doing site-to-site, that allows us to understand which point in time all these replication changes are taking place and whether they're synchronized. The process server does that. So we install this mobility service that allows us to sync the changes, allows us to communicate to this concept of the process server and the master target. The master target in this place being Azure Blob Store, where we're actually going to host the service. The other thing you need is a configuration server. So the configuration server, you don't need to deploy it. Azure does it all for you. You click to create the Azure Vault, the ASR Vault, where the blobs are going to go, where the replication is going to go. And as part of that process, you deploy a configuration server. You fill in the blanks, what you want to call it, what regions it's going to be in, what ASR vaults it's going to be connected to, all that kind of thing. You just fill in the process and away it goes. It's a tiny little VM. Storage cost, VM compute cost, next to nothing. Okay? Very, very straightforward. If we're doing physical to Azure, so we'll think about going from machine tin into Azure, there's a limitation on what we can work with. So 2012 R2, 2008 R2 SP1 is the minimum spec we can replicate here. There's a few then limitations around things like where the OS is located, what the machine's called. We can't replicate BitLocker disks. Your disks must be less than a terabyte in size. All those kind of things are just limitations in terms of what we can actually replicate here. I would imagine that most people, OS on C drive isn't uncommon, right? You had a weird environment, but OS on C drive is fairly common. Maximum 31 disks protected by per server. that's reasonable. If you've got more than 31 disks attached to a server, you're probably better off using a decent SAN vendor or a decent storage array somewhere else instead of having a whole lot of JBOD disks or 31 disks in a disk array. So just think about that as well. And server names. Anyone do server names longer than 63 characters? No. Last time I presented this, someone said yes, but that's interesting. So in terms of that, the things we need to do, it's very straightforward, right? We're just following the recipe. Okay, it's well documented on TechNet, well documented on Azure.com how you go through this process. And it's very simply wizard-driven within Azure, which I'll try and show you in a demo in a few minutes. So thinking about the planning, when we're thinking about a DR planning, think about those trade-offs. I mentioned already cost versus RPO and RTO. Okay, the smaller those RPO and RTO get, the higher the cost is going to become. With this ASR technology, you can get near synchronous replication, near zero RPO, right? Almost near to zero. ASR supports all our options, so when we think about what we want to do in terms of replication, failover, Hyper-V, VMware, physical, we can do all of them with ASR. Right? It allows us to do everything we need to do. A few simple scenarios. So RPO of 5 minutes, RTO of 1 hour. So ASR host or guest-based replication. RPO of 5 minutes and RPO of 30 minutes, which is kind of reasonable. We need to think about what we're going to do and what we're going to protect. So we might want to think about other things now. Not just about protecting a SharePoint farm, not just about protecting Exchange or file servers, but think about the rest of the infrastructure as well. The smaller you want those RPOs, and well, in fact, in this case, the more flexibility you want in the environment, the more you might want to think about controlling with ASR. So in this case, we're saying we're going down to 30 minutes now, so we're lowering our RTO. If we're lowering our RTO, we want more control with ASR. More control with ASR means let's add more of our infrastructure into the ASR feature. You might want to think, I mean, a simple scenario like the first one there, 5 minutes and RPO of 1 hour. When you're building out your infrastructure, you might want to say, well, you know what, I need Active Directory when I fail over, but I don't want to replicate my domain controllers. I'm just going to put another domain controller out in Azure, and I'll just use a site-to-site VPN, and we'll just use regular AD replication over that infrastructure. If the lower you go, the smaller your RPO and RTO get, the more tightly controlled you want the whole thing to be with ASR, because you want to make sure those domain change replication or the replicating domain changes happens in a frequency that's appropriate for ASR technology as well. You know, domain replication is about 15 minutes for most domain replication changes. ASR can do less than that. So I want to replicate my domain controller with those changes instead of waiting for those changes to replicate out. So just be aware of those kind of things. And then obviously the critical thing is to test that failover as well. You want to make sure that when you fail over, everything's working fine, that you can hit your RPO, that you can hit your RTO that you're aiming for. So the way we build this, this demo would take a long time, right? So I'm going to screenshot it as much as I can. Hopefully it's visible. The UI, when we're building an ASR infrastructure, the first thing we have to do is create a vault. So that's basically an Azure Blob Storage location. It's the vault that's going to receive our replicated changes. I'll show you some of this in the UI in a minute. Once you've created that vault, you then go through this quick start process. You've seen in Azure in the portal, if you've been in there, most things you build have a quick start page. You know, Blob Store has a quick start page, create some containers. Azure Vault has a subtly different quick start page. It starts to ask you things like, what do you want to protect? Download things like the components that you need to protect the environments you want to work with. Configure the sites that you want to protect. So I want to have a vault that's replicating a whole bunch of servers from on-premises. I'll create a site perhaps for, you know, primary SharePoint farm number 1, and I'll create a site that's going to be a logical container for those replicated changes. I then have to register my Hyper-V server, and this is a critical thing, okay? Azure has no idea about what you want to replicate, and you can't just start throwing things up there, just hoping that they're going to land in some blob store somewhere. You need to you download and run a component on the VMM server or the Hyper-V server, depending on what you're trying to protect. That component has the ability then to register that machine with the Azure Blob Store, and it's done through a process. You authenticate, and away it goes. You can't protect anything until you do that piece. You then define your protection policy. So and I'll show you this in a demo. Your protection policy is basically saying, how frequently do I want to replicate? How often do I want to check mark? how many replicas do I want to keep? So I don't want to keep like 10 years worth of replicas when I'm replicating and checkmarking every 5 minutes. Probably not. That's a significant storage. But it takes you through a wizard and you can walk through and configure that. Once we've configured our protection policy for that site, we can then add our machines. So in the ideal, so for a SharePoint specifically, any site that you create is going to want to contain all of the servers from the SharePoint farm. Okay, so they all get subjected to the same policy, which means they all replicate with the same interval. They're all check-marked with the same interval. And then you add those virtual machines and you add your disks into the site protection. The final piece, or second to last piece, is you create a recovery plan. And this is important. No point replicating things if I can't fail them over. Right? The recovery plan gives me the ability to do the final piece, which is a test, where I can just click on my recovery plan, click fail over or test fail over, and everything from on-premises that's been replicating over time will just come to life in Azure, hopefully, if you've done everything right, and you'll have an environment running in Azure that you can then play around with and validate your changes. It's that simple. Right? It's that simple. Your farms come up, everything's running fine. I'm just going to show you the UI a little bit. Like I say, part of this won't work, and I'll explain why when I get to it. If you give me a minute. Okay, so what we have here, now that I've learned how to zoom in after my last session, the first thing we needed to do was create this thing called an ASR, or go into recovery services. Down the bottom here in Azure, you can see there's a recovery services option. And we create a instance of the ASR recovery service capability. There's 3 you can see here: ASR demo, DTAP backup, and DTAP infrastructure. They're basically saying this is an ASR instance. I can have multiple sites in there. I can have multiple protected environments in there. This is just, they're all controlled using the same policy. If I drill into this, this is the quick start page. So now you see the options to say things like prepare VMM servers, which is basically saying download a registration key. You download the registration key that basically is, in effect, a SAS key, similar, right? Similar to a storage key where you'd access a storage layer. It's an authentication mechanism. It's a key that says I can use my VMM servers to communicate to this Azure Vault. I then download the provider, and that's the little UI we saw where you install the provider on the VMM host. Okay, or on the VMM server. The next thing is if your VMM server is controlling or managing multiple VMM hosts or VM hosts, you need to make sure you install the agent on all of the hosts. So you're basically building this mesh, this protection of this registration of all these machines. This is the bit that isn't going to work for me because over the weekend, all my VMs were moved to another host. A new one in my farm, in the farm back in Redmond, that doesn't have this component installed, unfortunately, and it won't be installed until we can do change control, right? Because we're doing proper stuff. Final thing, set the protection up for your clouds. You can map resources, so that's critical. You want to make sure that when your VMs come back online in Azure, they're mapped to an appropriate set of resources. Resources being network, for example. You want to make sure they're mapped to a network and they come up online on a network that say, for example, my network can see, or this network can see the SQL servers. It can see the Active Directory. It can see an instance of a load balancer. My users can connect to the environment. Those kind of things. So that's the kind of things you're mapping out to make sure that when you fail over, you have all the appropriate connectivity in place to be able to use the system. Then finally, we enable protection. So what it is I want to try and protect here, I can show you this, hopefully, is a group of servers. And I'm only going to do one because they do take a long time to protect. I'm going to try and do one anyway. You can see the one, Neil H server 01, right, is the middle one there is a SharePoint server, right? So SharePoint server running on a VMM host. There's a set of SQL servers there as well and a domain controller. In real world, we go and protect all of these, okay? For SharePoint, there's some things we're going to talk about which are a bit more specific, but I'm going to try and walk through configuration and protection of this machine. This machine is running in a cloud on a VMM server. It's a cloud called Neil H. Now, the VMM server has been properly registered with Azure, and we see that here. If I go to protected items, click on my VMM cloud, we can see the cloud, the Neil H cloud, in there, and it's configured to be a protected cloud. So that I've gone through that installation of the binaries on the VMM machine. I then need to add my individual machines in there. So if I open this one up, I can then do things like enable protection for certain machines. So I can see the same set of machines that we saw in the VMM instance. I choose server 01. I select the operating system. That's important because it's going to drop a base image and you need something to replicate into. Obviously for Azure to host these, you need to know what operating system it is. Which subscription am I going to put it in? And then storage account. And there's a glitch in the UI here, right? It doesn't show me the storage accounts, but they are there. Okay, that's something to do with this display. It's nothing to do with, in real life, try it, you'll see it. You'll get the storage accounts. And this should come through, hopefully. Come on. So we should get a message saying it's trying to protect. This is a West US subscription, so it's not the quickest place to put it, I'm afraid. Any questions while we're waiting? Seems like an appropriate time. One question? Yep.
How does it differ from like the setup stuff you're showing for nothing about targets or whatever?
So the question is, how does it differ? How does the configuration differ if I'm replicating site to site versus into Azure? So when I configure the ASR, most of it's the same. The agent that gets installed on the machines, when you configure, there's a section in the UI where you configure the target, and you can configure site to site rather than site to Azure. Okay, and then it changes the wizard changes effectively then in terms of how you configure it. Okay, but it's still using ASR to do that kind of orchestration piece. And I'm not seeing my machine. This isn't the demo bit that was supposed to break, by the way. Let's try it again. Give it one more go. Oh, there we go. So there's our machine in. You can see there protection couldn't be enabled, and there's a reason for that, which we'll see if I look at the error. So this failed, and the reason it failed, if I just go back, is because my machine doesn't have, let me go back to there. Sorry. We'll navigate the UI. So I mentioned the various components we need to install. Okay, right. You saw it, okay. You have to pretend it's still there, right, it's disappeared. When I tried to configure protection on that machine, the virtual machine host, where that machine's been moved to, doesn't have that second component installed. Okay, so protection failed, unfortunately. And because of our change control processes back at Microsoft, I couldn't just reboot the VM host because there's a whole bunch of other services running on there as well. I'll reboot the VM server, so unfortunately. What would have happened here, the enable protection, you'd have seen the machine pop up and it would have said protected. That then initiates the replication. And basically when we go in here, under configuration, we can start to look at what the replication policy is going to be, what the replication process is going to be. So we see here what storage account we're using to replicate into. You can see the target is Microsoft Azure. The target is specified when you create the ASR vault. You specify replicate to Azure, or you specify site to site, to answer the gentleman's question before. You then replicate, or you then configure the copy frequency and the retention policies. So in this case, we're saying copy the VM changes every 15 minutes. The retention policy, or the retain recovery points, is 6 hours. So every time I check mark my environment, I'm check marking in a 6-hour period, or I'll retain that period for 6 hours. Then the frequency of consistency snapshots is every 3 hours. So every 3 hours, I'm going to obtain an application consistent snapshot of my environment that I can know I can recover back to, and I'll keep them for 6 hours. So I'm basically saying I have 0, 3, and 6 three points in time that I can recover from at any point in time. And I can go back and back and back and configure this as much as I like. The copy frequency of can be much lower or higher. Lower 30 seconds. Remember I said about the replication strategy for Hyper-V is a 30-second window. So 30 seconds is a kind of the smallest RPO we can possibly get to in terms of recovery for data. There's a potential for a 30-second data loss, which is low, right? 30 seconds is one file change, or one upload in SharePoint, for example. Then finally, we can specify these replication settings that basically tell us when the configured Hyper-V host is going to replicate. So it's very, very simple to configure. VMware's just as easy, right? There's no real difference in terms of what you're protecting. And then when we've done all that in here, if I select the machine, down here you can see it says protection disabled because the host this machine is running on doesn't have that component installed, but we can drive all the protection from the VMM host as well, from the VMM console as well. Having said all that, how does that influence SharePoint? Because SharePoint's a weird beast, right? So if you're building these environments out, this is just a checklist to give you kind of an overview of what you might need. So from a proof of concept perspective, you can do the whole thing with one Hyper-V host. Very, very simple in terms of you just need connectivity to Azure. You can do this with free trial. ASR's available in free trials if you want to just play around with it. And the interesting thing is when you protect something with ASR, your ASR vault is free for 31 days. There's no charge. So if you're practicing and playing around, you don't want to pay any money, you can replicate out while you're playing around with it to test, destroy it, do another one, destroy it, do another one. Okay? Obviously, you wouldn't do that in production because that would be silly. There you go. So what about SharePoint? And SharePoint is a weird beast, right? We have issues with SharePoint, right? I love SharePoint. I've worked with SharePoint since it was before we even called it SharePoint. And when we're thinking about SharePoint, there's a number of components we need to protect. Azure, the Active Directory, SQL tier, app tiers, web tiers, search service application, and the networking. With the current version of ASR running on Windows Server 2012 R2, we cannot protect all of these with ASR, okay? Because we cannot guarantee that 30-second window that we have of replication means we could potentially have search service application and databases that are slightly out of sync. Okay, we can't protect the whole thing as what we call a protection group with ASR. We will be able to with Windows Server 16. Okay, so we're very close to being able to do this. We've got environments running with it now, but obviously not in production. With SharePoint today, if you want to do this, there's two ways to do Active Directory. Yes, we can protect Active Directory, so we can replicate AD to Azure, or we can just extend AD to the secondary site. So much the way you might do over Express Route or over a site-to-site VPN link, two domain controllers, one's running in Azure, one's running on premises, or two on each side, depending on what you need. Very straightforward. Extending your AD is quite important if you've got partial failover scenarios. So if you imagine a configuration where you're running just SharePoint, you're only protecting SharePoint, or you're only protecting Exchange, failing over everything's fine, right? But if you're running Exchange and SharePoint and file servers and other third-party applications, you don't want to have to fail over all of it just to test one of the scenarios. So having an AD extended into the other domain means it's always there and it's always up to date. The second thing is SQL Server databases. Now we make a dramatic departure from our regular support stance here. With ASR, we now support asynchronous replication of the farm config and admin content DB, right? There is no other scenario under which that's supported. Just to make that clear for the recording, right? There is no other scenario under which that's supported. We will support you if you do it with this configuration. So you can async replicate the config DB and the content DB and all the other databases except search, right? Search is the oddball. So with always on availability groups, we're basically saying here that with SharePoint, you replicate your AD, you use always on, stretched across on-prem to Azure for databases, including config and admin content. And then when we start to think about SharePoint, we start to think about replicating our SharePoint machines. We basically configure virtual machine replication, much like I tried to show you in the demo, and protect those machines into a vault. So now we have SharePoint servers replicating. We have SQL servers replicating over always on with all those databases. And we have AD doing its own thing, either extended or also replicating. This is the only supported configuration for SharePoint with ASR today. Okay, it's the only way you can do it and remain supported. So it's a bit fiddly. It's a little bit less fiddly than trying to do it any other way and build a second. So you don't need to build a second farm anymore. You don't need to manage change control in both places. You know, you're replicating those changes over. You're replicating the config DB. So all of your registrations, your sitemap, your solutions that you deployed or haven't deployed because you're using apps, all that kind of thing is being replicated. So you're significantly reducing the complexity of operations, even though on the surface it still appears to be a fairly complex approach. We've been running with this approach on our test rigs for SharePoint 16 internally at Microsoft for the past 12 months. And it just you can just literally flip-flop backwards and forwards with no data loss and everything comes up fine. The last piece is search. And I thought I had a slide for search. Do I have a slide for search? Sorry. Okay. Let's go through the configuration. I think there's a slide for search later on. The networking piece is important, as I said already. Make sure your networks get connected properly. When I bring my VMs up and bring them online, I want to make sure they're connected to an appropriate network that can see the AD that I've extended, that can see those SQL servers that I'm replicating to. So when my farm comes up, the machines come up alive. They don't come up complaining of unable to connect to configuration database, which I'm sure we've all seen on premises before. So that's important. That white paper on ASR networking is fantastic, and I think there's a session either today or tomorrow on Azure networking, which is really good as well. Second piece, DNS, critically important. Don't forget your DNS is probably routing to your production environment on premises, either through maybe it's an internet connected environment. So make sure you update the DNS. If your DNS is going to fail over and come up using a different URL, make sure you've got all your AAMs configured in SharePoint and test it, because if you don't test it, you've probably done it wrong. It's a nightmare getting the AAMs right. So make sure you configure that properly. Oh, here's search. And then restore search. So as I've said already, we don't support replication of the search index and replication of the search databases because we can't guarantee that with SQL always on and with virtual machine replication, we can't guarantee they're going to be in sync. And lack of synchronization between index and crawl means corrupt search index. So right now, the appropriate mechanism for search is to do a backup of your search service application on premises and restore it when you bring the VMs back up. It's a well-documented process. It's not the easiest process in the world to follow, I must admit, but it's basically a service application backup and restore. So it will work, and it does work fine. It's well-documented. The white paper there is one that I wrote a while back, but it's very solid, and it works if you follow it step by step. As we go forward with Server 16, you won't need to do database replication. You won't need to do search backup and restore. You'll just replicate all of it. And we'll have a consistent replication group across your databases, across search, and across the VMs as well. That's coming, but not quite there yet. The big picture for SharePoint, basically this is what you would build, okay? I kept this diagram into big pictures so I could understand it. On-premises on the left-hand side, Azure on the right-hand side. So S2S is your replication, site-to-site replication. So we might configure a site-to-site VPN link there, for example. SQL always on for your databases. ASR replication for SharePoint. ASR or AD replication, as in extend and just allow the regular AD replication traffic to look after that. And then thinking about the outside piece is our networking. The little laptop picture in the middle there, just below where it says public endpoint, is thinking about an on-premises laptop, where it's much easier to control your DNS on premises. When you're outside coming in, you might have to think about updating your public DNS, updating an appropriate Azure Traffic Manager endpoint that routes the traffic between the original on-premises environment and Azure. So you make sure you're connecting to the right locations. So it looks complicated on the covers. It isn't uncomplicated, but it isn't difficult. And despite my demo not working, I've done this several times, and it's fairly straightforward. And we're going to do a webcast on how you do it end-to-end, click by click as well. So, in terms of failover and failback, I'm almost out of time, a few minutes. There's some different modes, so think about your failover. And the line on the bottom of that thing is critical. Remember we said we can support replication of the configuration database? We can, but you have to then perform another action afterwards. And the action you have to perform is to flush the config cache. Okay? That's important because the machines are not being replicated at the same synchronization point as the config DB. When you flush the configuration cache on the machines, you basically bring your machines in sync with the configuration database. There is still the potential for some loss. Okay? If your configuration, say you registered a site, you created a new site collection, and that hasn't replicated across yet, then you might lose that new site collection registration in the config DB. So, but it's disaster recovery, right? There's always the potential for data loss with disaster recovery. The chances are, how often do you create site collections? Not very often. Is there a possibility you'll be just creating a site collection at the point at which you fail over? It's probably unlikely. Okay? Don't do it. Don't try and test that because it probably will break. But in terms of an unplanned failover, when things are going drastically wrong, I don't care that the site collection I just created isn't there anymore because I didn't put anything in it yet. Right? I just care about what I had and what my people are using. Test failover I mentioned already. Really, really, really useful feature. Right? To be able to just go test, or you click on the network, you confirm that it's a test failover, and it spins all those machines up, and everything fails over and comes online in Azure without taking down on premises. So your users don't care. They're still working and using the environment on premises. You spin up that test environment. You can log in. You can test it. You can run your validation scripts all against that an ASR environment. And then when you're finished with it, ASR will tear it all down for you as well, and then just carry on replicating as before. Very, very useful test feature. Thinking about the concept of planned versus unplanned failover, when you do the different approaches, you can choose or you can select what type of failover you want to do. So thinking about if it's an unplanned failover, I'm just going to force that failover. If I'm doing testing, for example, I can then just go in and manage it and choose, I'm doing a planned failover, therefore I know that when I'm doing a planned failover, all of the changes that are synchronizing into my VMs are going to get caught up before the machines actually fail over. When it's unplanned, I could potentially lose some of that data in transit, okay? Because I've got changes on machines over here. If you imagine I just severed the network, there's some changes I might not get. And I have to confirm when I'm doing that failover that I want to just ignore those changes and take that risk, okay? Which is just the same as if you do a SQL failover. Config cache flush, those are your steps to do config cache flush. Cache flush, I should say over here. That's right, isn't it, Wayne? That's a PowerShell process for doing it. There's a whole number of documented processes for doing it, like logging onto machines and stopping the timer service and stopping the admin service and modify the cache file, delete the XML files, all that kind of thing. That'll do it for you. Nice and easy, very straightforward. Then the last piece is really fail back. If I'm failing back, again, it's almost the same process, but just in reverse. We fail over for SQL, we fail back with SQL always on. If any of you are using SQL always on and have failed forward and backwards, it's a relatively straightforward process, especially if you've not actually got a disaster, because then all your changes are caught up and it's much simpler. Fail back the ASR, so we're failing back to on-premises. So we fail back and on-premises, if we're entirely virtual, our updated VMs in ASR now get replicated back to our VMM machines on-premises. They become the master target, or they become the master service, and then we start replicating back to ASR again for DR capability. We recover search in the same way, back up and restore. So if you were running for a period of time in Azure with your machines in a disaster recovery scenario, you want to make sure you've got a process to back up that search service as well. And obviously, going back the other way, you flush the config cache again, because we're failing back the unavailability groups for config DB. So with that, just a quick overview of the currently available application-aware ASR solutions. Almost everything. We've done a lot of work in the last 18 months to validate these solutions for all of what we call our hero applications. And I'm proud to say that SharePoint was the number one hero application. It's the one they went after the hardest. So we fully support SharePoint. Hyper-V to Azure, Hyper-V site-to-site, VMware site-to-site, and soon site to Azure as well with VMware. So we're going to cover the whole spectrum. So with that, I'm done. There's a few interesting sessions you might want to go and see as well. That VMware session was, well, okay. There's another one running this yesterday at 13:55. Interesting for the people using VMware and ASR, not necessarily for SharePoint, but VMware and ASR generally. Azure infrastructure, getting ready for SharePoint, useful as well. And obviously, I'll call that Brian's session again. The desired state configuration for SharePoint is useful for building out these SharePoint farms before you go replicate them. So that's it. I'm done. I appreciate your time. Thank you for listening. And any more questions? One over there. They are do the best. Sorry. So the question is, when you're replicating your machines, is there a license implication? So if I have 10 machines on premises and I'm replicating 10 machines into the cloud, do I need 20 licenses? And I have to validate this to be 100% sure, but my understanding is no. The machines you have on premises, you license those. When you fail over, because you're not running those machines at all, you don't need licenses for them. It's much like the SQL cluster scenario, right? It's the same idea. We can take that offline and just 100% confirm that, but I'm 99.9% certain that's true. Yeah.
Regarding the test failovers, how much sandboxing is there around these machines being fired up just as a test? And how does that relate to things that are replicated outside of ASR, AD and SQL and so on?
So they're fired up in a separate storage vault, and they're disconnected from everything else. It's a bit more complicated with SharePoint because of the always-on stuff, but you can test the machines themselves. So the actual test failover for a SharePoint farm is a little bit more complex. And to repeat the question, is the test failover sandboxed or isolated? Could it interfere with other scenarios? It's designed not to. With SharePoint, it's more complex, though, like I say, because the SQL always-on thing, you want to think about failing all those pieces over. You could use, in theory, with SharePoint, if I'm doing always-on availability groups and I'm using readable replicas, my farm's going to come up, okay? And I can run readable replicas with a test farm, so I should be able to do that just fine. I have to admit, I've never tried that, though. Any other questions? No? So thank you very much.